in lots of different sites, which are sometimes very, very different from the site that actually has produced the data in the first place. So the way in which the project worked was very much working with an approach that was very qualitative, so from the philosophy, history, and studies of science, partly because there's basically no way to document the travels of data really at this point. So people are trying to micro-tag them, the tag gets lost pretty much immediately. So the only way is to physically follow the data, and I can assure you this was very, very difficult to do, because digital things move fast and they move in unpredictable ways. So it took us several years to try and reconstruct some of these trajectories. So the way which we did it was to really start from looking at databases and data curation enterprise and institute, then go and look how data were being used, and then reconstruct back what it meant in terms of where data actually were coming from. So just to kind of give a visualization of this kind of work, what we did is to try and go from follow data from sites of data creation to sites of data mobilization to sites in which data were actually being interpreted. And the interesting thing, of course, is that in order to really move data away from the place in which they were originally produced, you have to some extent to decontextualize the data. You have to choose actually what are the data in all the objects that are being collected by particular groups. You have to decide metadata. Right? And of course, to do that, you need to be very careful about what is your vision for how data will in fact be recontextualized in a new site. What will people who are using the data need as additional information to be able to make any sense of the data and to actually reuse them for their own purposes? So, just to give a few examples of the kind of work and the kind of cases we've been following. I'm going to give you first some examples from the plant science agricultural realm, which I'm also very interested in. And here we're looking at an example from Wales of the National UK Centre for Phenotyping of Plants. So what you have is lots of plants that go around in basically kind of little platforms and robots that bring them around and image the morphology of the plants in a variety of different ways. So we looked at the complexity, actually, which it takes in terms of preparing a visual environment in order to create images that then could be potentially disseminated and reused and actually be of some use to people that are outside of this particular facility. And we're still doing quite a lot of work with a Nigerian center. In fact, I mean, the whole of the CG, the Consulting Group on Agriculture, but particularly the International Institute for Tropical Agriculture in Nigeria, in Ibadan, where they're doing a lot of field trials on cassava. You see that here. And there is a lot of work going on there in working on kind of field book collection tools that would allow you to collect data straight from the field and then circulate it, in fact, in a completely open way here. It's not even fair, it's just open. Like to anybody who would be interested in getting results from those particular experiments. So as you can see here, you can go collect data directly in the field. And we looked at, of course, I'm particularly personally interested in ontologies and the semantics of how you actually achieve this, especially when you're doing data collection. Of course, there's a lot of this also in Brazil, like data collection in many, many different fields around the world, across many different languages, and with very different cultural traditions about how you call different plant traits and which plant traits are actually valuable in different situations. And so a lot of work on things like the crop ontology, which is essential for this kind of dissemination. And then looking at how data saved from that particular location would travel to many different institutions around the world, from big corporations to important international agencies like the Food and Agriculture Organization, to big universities, in the States, some in Europe, some in other places, and generally now with the big data platform across the whole consulting group of agriculture. So now coming to data linkage, we started to do a lot of our work in thinking about how do you even connect data which are acquired within biology and biomedicine on different organisms. And that's because that's basically where my expertise really, my interest in this kind of topic started. So for instance, we looked at situations where data collection on yeast, so fish and yeast and bacon yeast, one of the very important model organisms for biological research, was aggregated in ways that would allow for inferences straight from the regulation of the cell in yeast to the regulation of the cell in human cancer. And this is because there is a big body of evidence, which is basically being collected thanks to the databases set up in that way, that proves that the way in which we understand the mechanism of cell disruption in yeast is actually very similar and can teach us a lot about what is going on in cell regulation in oncology and cancer. And one of the interesting things here was to look at the fact that these kind of databases were really crucial for doing this kind of work. And at the same time, so I'm not going to really read through this quote, at the same time, really the reason why this whole program worked was because the people that were using database were in fact working very collaboratively with the people that were setting up the database. There was a division of labor, but there was also a lot of iteration between people that actually were using database and people who were setting it up. And in fact, it's one of the very, very few data structures that we know where the users of the data, more than 50% of them, contribute to annotate the database, right? So there's a lot of labor that goes back and forth here, which of course is very difficult because it's not scalable. I mean, when you go to one of the big medical databases, you cannot really do this kind of work anymore. The community is too big, and the work to be done is too big, and there's too much controversy, so that just cannot happen in that same way, which I think is interesting. And in fact, this is one of the situations where that's exactly something that cannot happen. This is a case of data linkage. This is the most important, arguably, database for cancer research. It's called the COSMIC database. It's local somatic mutation relevant to the understanding of cancer. And this is a database that many people in clinical research also are accessing and using regularly. What is interesting about this is that it's everything but automated. So it's completely manual. A lot of the work that they're doing is having curators within this database that are specialized, each one curator per gene, right? Become specialized in one gene, in one particular set of traits, and would follow that through the literature and make absolutely sure that the knowledge that is being kind of summarized and included in this database, in fact, is valid and is reliable. And it's very interesting because, again, these examples like this, and actually that's one of the reasons why it's such an important database. At the same time, it's an interesting demonstration of how far from automated these kind of services are. They're very labor intensive and they require a lot of ingenuity and a lot of thinking. Another case that we looked at, which again is almost the other side of the spectrum now, is data linkage across hugely diverse and huge data sets. So this is what many people in epidemiology call data mashups, which is the attempt to just bring together pretty much any big data set that you can have that you think could help you to answer very big questions about public health. In this case, we looked at case of the MEDME data mashup and database that were produced by the University of Exeter in collaboration with many other entities around the UK. And this was an attempt to bring together environmental data, climate data, data from hospitals, and biological information, biological data, to understand, for example, the seasonality of air communicated pathogens. So how do they move around? When are they more likely to actually disseminate, to be present and therefore to cause respiratory disease? What does it mean in terms of setting up hospitals and in terms of setting up services that could respond to that, etc., etc. And the interesting thing, of course, is to look at how, and we have a few studies very much in detail about how people have really done this. And one of the interesting things is how important it has been in these situations to keep a very clear trail of where they were actually coming from in the first place, and the history of what had been done on the data, so that people who actually were on the other end and trying to establish whether the inferential claims that were taken out of the system actually made sense in terms of, can we rely on them, could in fact, if they wanted to, go back and consult that trail of data work, if you want, that preceded a consultation of a database like this. And then we looked at the situations where there are institutions that start off as institutions where the key priority is basically to make data secure, particularly biomedical data, and to de-anonymize them so they're actually secure and can be handled even in their personal data. And this was the case of the Secure Anonymized Information Linkage Data Bank, which is a very, very important center for the security of data based in Wales, in the UK. And one of the interesting observations there was to see how an institution like this, which has now been going for more than 15 years, gradually transformed itself from a place where there were supposed to just be technicians that de-anonymize the data, and then the users would come and the user would decide what to use for the meaning of the data, into an institution that is actually helping researchers to shape the very questions of research that they should be asking, because nobody knows the data better than they do. And so there's a lot of expertise coming from these kinds of initiatives that ends up going back into research in the form of a real research collaboration. And I mean, I think there's a lot of these similar situations that I could see yesterday in Cidacs when I was hearing these presentations. So, some lessons learned. I'm going to go through them relatively quickly, but we can come back to them. Well, first of all, I mean, I'm very interested in data semantics. How do we call the things we think data are about? And this is really important, and I keep being kind of amazed actually at how easily sometimes this question is being sidelined, particularly by people who are working in computer engineering, and so they're very removed from the environments in which people will be trying to interpret the data for particular purposes. And so data semantics do determine how data are incorporated into machine learning algorithms, obviously, very important. They determine which data are linked with each other and how, which claims and about what data are actually taken as evidence for, whose knowledge is legitimized in a broader social and political sense within these databases, who is being represented, who isn't, if you want, and which knowledge is being excluded from data science and AI, and which perspective is incorporated in data-driven systems, because typically a semantic system is based on a particular theoretical perspective, right? And there's going to be many around, and there's going to be decisions made about how do we, in fact, interpret the terms that go into setting up databases and so on. So,